was one of the things that, the sort of 4 or 5 things I thought would really affect the future dramatically.
At the peak of the Cold War era space exploration race, 3 cosmonauts from the Soviet Union, who were part of the Soyuz-11 mission, tragically perished. Recently, Elon Musk revealed the terrible truth about the brutal deaths of these 3 Soviet cosmonauts. Who were these cosmonauts? What happened to them? How did their deaths affect the future of space exploration? And how does Elon's revelation tie into the matter? Let's dive into this and even more. Today's space exploration rivalries, as seen between the SpaceX and Tesla CEO Elon Musk and Russian space agency CEO Dmitry Rogozin, may boil down to a couple of snide comments on social media, but there was a time when the future of the world depended on who won. Not to say that it does not today, but perhaps in a different way now that we're past the Cold War era. Elon Musk, the visionary founder of SpaceX, and Dmitry Rogozin, the Director General of the Russian space agency Roscosmos, have been engaged in a dynamic space rivalry. This has naturally captured global attention, although not for reasons you'd think. This rivalry features nothing more than a series of playful banter, cutting remarks, and occasional shifts between cooperation and tension. Their interactions on social media and public statements clearly show how the 2 aerospace giants are not immune to the competitive nature of the space industry and the ongoing geopolitical tensions between the United States and Russia. In 2014, following Russia's annexation of Crimea, then part of Ukraine, the United States imposed financial sanctions on several Russian officials, including Rogozin. Rogozin responded with a tongue-in-cheek remark suggesting that NASA should use a trampoline to send its astronauts to the International Space Station instead of relying on the Russian Soyuz spacecraft. This was a jab at the United States' dependency on Russian technology for transportation to the International Space Station at that time. However, on May 30th, 2020, NASA and SpaceX successfully launched the Demo 2 mission from the Kennedy Space Center in Florida, carrying NASA astronauts Robert Behnken and Douglas Hurley to the ISS on a Crew Dragon spacecraft named Endeavour. SpaceX CEO Elon Musk returned the long-overdue favor with his characteristic humor, stating during a press conference that the trampoline is working. 2 years later, things took a turn for the worse when, in May 2022, Rogozin accused Musk of supplying Ukraine with Starlink terminals and supporting what he referred to as fascist elements. Musk took to Twitter and joked how he couldn't die under mysterious circumstances, as was the case with many dissenters in Russia. But this is nothing more than a small, insignificant episode in the larger context of US-Russian rival spacefaring ambitions. Let's dive a bit into the US-Russia space rivalry. The space race between the United States and the Soviet Union is one of the most enduring competitions involving soft power. And considering the context of the Cold War era, this was one of the ways which would influence the future of the world, whether it was the US or the USSR that would lead the world into the coming century. The Soviets beat the US to the punch by launching their satellite, Sputnik 1, on October 4, 1957, marking the beginning of the space age. This was a big deal as it showed that of the two, the USSR was the superior technological power. But it didn't take the US long to respond by forming the National Aeronautics and Space Administration, or NASA, in 1958, and launching their own satellite, the Explorer 1, on January 31st of the same year. But they were lagging behind already. Just 3 years later, the Soviet Union achieved another major milestone by sending Yuri Gagarin into space in April 1961, making him the first human to do so. This was twice that the USSR had beaten the US to the punch in the space age. The response? US President John F. Kennedy appeared on TV screens all over the nation and pledged to land an American on the moon before the end of the decade. Of course, the USSR was aiming for the same, and this was a race that both sides were desperate to win. 2 years before the pledged period's end, NASA's Apollo program achieved this goal with the Apollo 11 mission in July 1969, which concluded successfully when Neil Armstrong and Buzz Aldrin became the first humans to walk on the moon. With the moon race concluded, Both nations shifted their focus to space station development to establish a more permanent human presence in space. For this, the Soviet Union launched the Salyut-1 space station on April 19, 1971, again beating the USA to the punch. In response, the US successfully launched the Space Shuttle Columbia in 1981. The USSR also launched a second, bigger, and more ambitious space station, Mir, on February 20, 1986, but by now the Soviet bloc was facing economic challenges. Around a decade later, it was not in space, but on land where the USSR tasted its final bitter defeat in Afghanistan before being dissolved ultimately on December 26, 1991. This did bring the Cold War era to an end, but the newly found Russian Federation did not give up on its space ambitions. Of course, now it was a matter of cooperation with the West rather than rivalry. In 1995, the Space Shuttle Atlantis, OV-104, docked with Mir, symbolizing improved US-Russia relations in space. And just 3 years later, both nations became partners in the International Space Station program, which began construction in 1998. Fast forward to the present. The rise of space companies like SpaceX introduced new players and dynamics to the game. Of course, the situation was not helped by Russia's annexation of Crimea. By the time the US began sanctioning individuals and entities in Russia, it already depended on Russian Soyuz rockets for access to the International Space Station. The USA now needed domestic alternatives. SpaceX successfully filled the gap with its Crew Dragon spacecraft. While Musk's response to Rogozin's earlier trampoline comment hit the headlines, his observations about the much earlier doomed Soyuz-11 crew is what has many terrified. Let's dive into the forgotten story of the cosmonauts of Soyuz-11. The ill-fated mission of Soyuz-11, the crew's untimely death, and the secrecy surrounding their deaths due to the political climate of the Cold War era have lessons for us all, but more importantly, for all spacefaring nations. The Soyuz-11 was a Soviet space mission launched on June 6, 1971, to dock with the world's first space station, the Soviet-made Salyut-1. The crew consisted of 3 experienced cosmonauts: Georgy Dobrovolsky, Viktor Patsayev, and Vladislav Volkov. None of them made it back alive. The initial part of the mission was a success. The Soyuz-11 spacecraft docked with Salyut-1, and the crew spent nearly 3 weeks aboard the space station, conducting scientific experiments, observations, and testing the station's systems. Following this, the crew headed back home, but on June 30, 1971, tragedy struck during the crew's re-entry to Earth. A cabin vent valve in the descent module opened prematurely while the spacecraft was still in space. This caused the cabin to depressurize. All 3 cosmonauts on board perished. The biggest irony is that these men were not even supposed to be in the descent module. The original crew consisted of Alexei Leonov, the first human to conduct a spacewalk during the Voskhod-2 mission in 1965. Valery Kubasov, an engineer and cosmonaut who had also participated in the Soyuz-6 mission beforehand. And Pavel Belyayev, who commanded the historic Voskhod-2 mission in 1965, however, just 4 days before the launch. A medical X-ray examination suggested that Kubasov might have tuberculosis. In reality, this was an allergic response that the medical team had mistaken for tuberculosis, but the entire team was replaced with the backup crew. This sense of rush to send Georgy Dobrovolsky, Viktor Patsayev, and Vladislav Volkov instead of the original crew, according to Musk, underlined the general sense of rush in the matters. The Soviets had, perhaps mistakenly, not taken enough time with the project. Whatever the case, as the cabin depressurized, the crew would have experienced lost consciousness within seconds, never to wake up. The descent module landed safely in Kazakhstan, but it was when the recovery team opened the hatch that they realized what had happened. The crew members were all motionless and unresponsive. Medical examination confirmed their deaths. The circumstances of the crew's deaths were kept secret by Soviet authorities, likely to give the impression of success. And of course, the political climate of the time also played its part. While the public was unaware of the tragedy until much later, the crew's families were also not informed about any details concerning the deaths of their loved ones. It wasn't until 1976 that Soviet officials officially acknowledged the cause of death. Due to this lack of public recognition and secrecy concerning their deaths, the crew of Soyuz-11 is often referred to as the Forgotten Cosmonauts. The incident led to improvements in spacecraft design, safety protocols, and crew training to prevent similar accidents in the future. Posthumous recognitions: the Forgotten Cosmonauts, Georgy Dobrovolsky, Viktor Patsayev, and Vladislav Volkov all received posthumous recognitions and honors for their sacrifice and contributions to space exploration once the information was unveiled to the public. These honors included the highest honorary title in the Soviet Union, the title of Hero of the Soviet Union. The trio was also awarded the Order of Lenin and the Order of the Red Banner of Labor posthumously, both prestigious awards in the Soviet Union. Additionally, 2 asteroids were named after them: 1671 Chaika, Volkov, and 1791 Patsayev. The USSR also erected several memorials and monuments to commemorate the Soyuz-11 crew. One such monument is the Memorial Museum of Cosmonautics in Moscow, where their achievements and sacrifice have been immortalized. The sacrifice of the Soyuz-11 crew also garnered recognition and respect from the international space community. Their names will go down in history, as do right now, alongside other space pioneers who gave their lives in the pursuit of exploration. But what were the technical issues behind the accident? Let's take a deeper look into what happened. The tragic Soyuz-11 mission was not just a result of human error or individual sacrifice. It was a result of a series of technical breakdowns. Of course, considering the complex and intricate nature of space travel, one must understand that even the slightest oversight can have catastrophic consequences, as it did for the doomed crew of the Soyuz-11 mission. One of the key technical failures of the mission was the pressurization issue during re-entry. As Soyuz-11 began its descent back to Earth, a cabin vent valve that should have stayed closed during re-entry failed to do so. This led to a critical loss of cabin pressure, which proved fatal for the crew. The valve's malfunction caused the crew module to depressurize. Depressurization is the reduction or loss of air pressure in an enclosed space, such as a spacecraft. In normal conditions, the human body is adapted to function at a specific atmospheric pressure, which is the pressure exerted by the Earth's atmosphere. Depressurization can occur when the pressure in an enclosed space drops below the level that our bodies require to function properly. This subjected the cosmonauts to the harsh conditions of re-entry without the necessary life support. They must have lost consciousness soon enough in the oxygen-deficient environment and asphyxiated to death. The crew's inability to respond effectively to the pressurization failure also contributed to the tragic end. That is not to say that the crew could have done much. There were emergency procedures in place, but the rapid descent and the lack of time prevented the crew from taking corrective actions. The Soyuz spacecraft at the time also did not have any advanced automation and redundancy systems that modern spacecraft possess. Thus, the crew was left with limited options in the face of such a crisis. Another problem was with the Soyuz spacecraft itself, and perhaps this is what Elon Musk was alluding to when commenting about how matters were being rushed. While a workhorse of the Soviet space program, the design of the spacecraft and its systems were a product of their time, with certain limitations that became evident during the mission. The spacecraft's re-entry and landing systems, as well as its life support systems, were not robust enough. This was addressed in later generations of spacecraft. Another problem was communication, more precisely, the lack thereof. During the Soyuz-11 mission, communication was lost during re-entry due to the ionization of the Earth's atmosphere. This communication blackout prevented mission control from receiving crucial information about the crew's condition and any potential issues that might have arisen. The tragic revelation only dawned upon the recovery crew when they opened the hatch and found all 3 crew members lifeless, as we discussed earlier. But how did the spacefaring nations change their approach to safety in the aftermath of the Soyuz-11 tragedy? The tragic loss of the Soyuz-11 crew had a profound impact on future safety protocols and spacecraft design not only in the Soviet Union, but worldwide. The legacy of the Soyuz-11 sacrifice catalyzed improvements that would ultimately make space travel safer for cosmonauts and astronauts. While the USSR tried to keep most of the facts behind closed curtains, the deaths did prompt an immediate investigation by Soviet space authorities to determine the cause of the accident. Space experts analyzed telemetry data, reviewed mission logs, and examined the spacecraft's design and systems to dig out the main culprit. The investigation revealed that the accident was a result of cabin depressurization during re-entry. This led to the development of enhanced cabin pressurization systems and more rigorous procedures to prevent such incidents in the future. Procedures for sealing off sections of the spacecraft were also refined to ensure the safety of future crew members during re-entry. The Soviet space program also intensified its focus on emergency escape systems for crewed spacecraft. They improved launch escape towers and mechanisms that would allow crew members to quickly and safely evacuate the spacecraft in the event of an emergency during launch or ascent. Naturally, a reinvigorated effort for thorough crew training, including emergency scenarios, also followed. Cosmonauts were trained extensively to handle various contingencies and emergencies, allowing them to respond effectively under stressful conditions. The design of the Soyuz spacecraft itself was also revised to incorporate safety enhancements based on the findings from the accident investigation. Engineers shifted to improved materials, ensured a stronger construction, and introduced more robust systems to ensure the structural integrity and safety of the spacecraft. All of these efforts converged in the development of the Soyuz-11 KT spacecraft, an improved version of the original Soyuz. The Soyuz-11 KT featured enhanced safety measures, improved cabin depressurization prevention, and upgraded re-entry systems. To this day, the incident serves as a reminder of the risks involved in space travel and motivates efforts to improve spacecraft design, engineering, and operational procedures. But there was a human element to all of this as well. The tragic mission of Soyuz-11 left the families of the cosmonauts, who were even denied the details regarding what led to the deaths of their loved ones, grappling with an immense loss. We often look at tragedies like this in terms of money or failure, but there's a deeply emotional perspective as well. Accounts of the families of Georgy Dobrovolsky, Viktor Patsayev, and Vladislav Volkov reflect the pain, pride, and grief that coexist in the wake of such a tragedy. The private writings of the cosmonauts themselves also provide a unique insight into their thoughts, hopes, and fears as they embarked on their grand journey into space. The letters and diaries of the Soyuz-11 crew show their determination and enthusiasm for advancing space exploration. They reveal their intellectual curiosity and passion for unraveling the mysteries of the cosmos. These writings also reflect the bonds formed among crew members during the mission. Beyond the tragedy, the doomed Soyuz-11 crew continues to inspire astronauts and cosmonauts who continue to push the boundaries of space exploration. There have been several accidents involving space missions since the Soyuz-11 tragedy, and we continue to evolve protocols and technologies accordingly. Space exploration is inherently complex and risky, and while significant advancements have been made in safety and technology, accidents and failures can still occur. The Challenger disaster, for instance, is a stark reminder of how even the smallest mishaps can have the most disastrous consequences in the space exploration business. On January 28, 1986, the Space Shuttle Challenger disintegrated just 73 seconds after liftoff due to the failure of an O-ring seal in one of the solid rocket boosters. The crew of 7 had no chance. They all perished. Decades later, on February 1, 2003, the Space Shuttle Columbia disintegrated upon re-entry into Earth's atmosphere due to the damages that the thermal protection system sustained during launch. The crew, again 7 lively souls, were lost in the tragedy. A more recent accident befell the Soyuz MS-10. On October 11, 2018, the Soyuz MS-10 spacecraft, which was carrying 2 cosmonauts to the ISS, experienced a booster separation failure during launch. But in this case, tragedy was avoided as the launch escape system carried the crew module away from the rocket. The crew returned home, safe and sound. Though tragic, these events have not stopped mankind's ever grander strides in space exploration, but they have allowed us to reevaluate our safety protocols. Today, spacecrafts boast multiple layers of safety, which was not the case with Soyuz-11. But still, space exploration remains a risky business, to say the least. Accidents threaten all efforts to explore the space arena, but we have adapted accordingly to conquer space travel. Since the Soyuz-11 tragedy, space missions have encountered numerous accidents that have prompted continuous refinement of protocols and technologies. The intricate nature of space exploration, coupled with its inherent risks, has led to substantial safety and technological enhancements. However, these advancements have not eliminated the potential for accidents and failures. The devastating Challenger disaster of 1986 serves as a poignant example, emphasizing how minor oversights can result in catastrophic outcomes. Similarly, the loss of the Space Shuttle Columbia in 2003 underlined the criticality of robust thermal protection systems. More recently, the Soyuz MS-10 incident demonstrated the significance of launch escape systems. While these tragedies underline the dangers, they also drive improvements, cultivating a safer environment for humanity's unending voyage into space. Thanks for watching. Don't miss this video you see on your screen right now. It's truly unbelievable.